Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, S3 compatible object storage, and worldwide data centers. Go to pythonpodcast.com/Linode, that's Linode today, and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macey, and today I'm interviewing Austin Parker and Alex Boten about the OpenTelemetry project and its efforts to standardize the collection and analysis of observability data for your applications. So, Austin, can you start by introducing yourself?
Sure thing. Hi, I'm Austin Parker. I'm Principal Developer Advocate at Lightstep, and I'm a maintainer on the OpenTelemetry project.
And Alex, how about you?
Yeah, sure. Hi, I'm Alex Boten. I'm an open source software engineer at Lightstep, and I'm a contributor to the OpenTelemetry project, as well as one of the maintainers on the OpenTelemetry Python project.
And so going back to you, Austin, do you remember how you first got introduced to Python?
Oh, actually, I think probably the first time I ever used Python was way back in college. I feel like that's, I want to say maybe my, intro to programming type of thing. Before that, I done a lot with just general scripting, things like AppleScript on my Mac, and other forms of, like bash scripting and shell scripting. But Python was kind of new to me, and I really enjoyed it, actually. I still love to work in Python.
And Alex, how about you?
Yeah, so I guess I remember the first time I heard about Python was people complaining from the Java world about the white spacing that Python required. But, at the time I hadn't really used it. And I was really introduced to it about 6 years ago when I joined a team that was building a platform as a service, and the API and the CLI were all written in Python on top of Docker. And so basically I jumped in and I just needed what I needed to learn the team move forward using Python 2.7 at the time, I think.
And in terms of the OpenTelemetry project, can you each give a bit of background as to how you each got involved with it and maybe describe a bit about what the project is and some of the story behind it?
Sure, I guess I'll start off. So I actually came into OpenTelemetry from one of its predecessors, OpenTracing. Kind of the short version of the story is in, I want to say 2016, 2017 or so, OpenTracing came out as an open source project, and the goal was really to provide a standard unified API for distributed tracing across multiple different languages. So everything from Java to Python, C#, and so forth. And this, the underlying idea here was that distributed tracing was, very useful, but often people would apply it in sort of a polyglot environment where you had some services running in Node and some in Python and some in Java. And you want to be able to, for distributed tracing specifically to be useful, you really want it to be able to kind of go through the entire request, nose to tail, as it were. So you need some standard idioms, and you need some standard, think about it as adjectives and verbs, right? You need these standard things between your different languages. So OpenTracing was designed to fill that hole in the ecosystem, and it was an API, that had to be re-implemented by different vendors. So you would have a Jaeger implementation or a Zipkin implementation, but your actual tracing code was independent. So I could use the same tracing code with any number of vendors, and it was great. Now, in reality, maybe it didn't work out quite as well as we had hoped. 2018 or so rolls around, 2017, 2018, I want to say, you saw OpenCensus kind of arrive as a competitor to OpenTracing in a lot of ways. And OpenCensus was a Google project. Microsoft also joined in. And it had a similar sort of concept. It's like, hey, we want ubiquitous tracing. We want it to be polyglot. But we want to provide sort of both the API and the SDK. And then let you have a pluggable sort of exporter model. These two projects coexisted for a while, but it was causing confusion in like the broader open source community. People weren't sure which to use. I had open source library authors come and say like, well, I have customers or I have users that want to use tracing, but which one of these two things should I pick? And ultimately, I think what happened really is everyone sort of looked at the situation and said, hey, this is definitely a time where we can be better together, right? We don't need these two competing standards. It's driving down adoption rather than driving it up. So let's kind of join forces. Let's do a best of both worlds approach. And out of that, was born OpenTelemetry.
And Alex, how did you get involved in the OpenTelemetry project?
So I actually came out of it from the other side. I was a user of both OpenTracing and OpenTracing. So I was right in the middle of all that confusion about I don't know, maybe a year and a half, 2 years ago now, and I was introduced to the OpenTelemetry project, much like everybody else on the user community, around the announcement that was done about a year and a few months ago now. And I really joined the project as a contributor when I joined Lightstep about 7 or 8 months ago now. And that was my first real introduction to the project.
And so the tagline of OpenTelemetry is that it's trying to help make observability data easier to collect and access. And before we get too much further into the specifics of how it does that, I'm wondering if you can give a bit of a definition as to how you think about observability and in what ways it's separate from the quote-unquote traditional approach to monitoring, where you're just collecting different metrics and shipping it off to some host for being able to aggregate them there.
That's such a great question. I think if you kind of look around, there's a few different definitions of observability, but I like to talk about it and think about it in a pretty simple way, which is observability is about understanding. And it's about having the ability to understand your system, your system's dependencies. It's about being able to understand not only sort of the aggregate behavior of a system, in production, not isolated and not in some sort of synthetic way, but actually to look at traffic as it goes through your system, look down at the individual request level if you need to figure out, what is wrong with this one request, but also to be able to kind of pull back to that 30,000 foot view and understand the entire thing, how all the pieces fit together. And having both that very coarse and fine visibility into what's going on means that you can do a lot of interesting things that you can't do with traditional monitoring. There's the sort of common, unknown unknowns theory, right? Where when you're building a system, when you're running a system, even you don't know. It's not the things that you know about. It's not the metrics that maybe you're collecting and that you think you care about at the beginning. And it's not the things that you sort of discover. The things that are going to bite you are the things that you don't even know about that you should know about, right? So the whole principle of observability, as it kind of gets down to this instrumentation level, which is where OpenTelemetry really plays, is you need to have an SDK that can help you effortlessly collect a lot of different data points and has a pretty deep integration into your underlying frameworks and tools, and then ship that off somewhere to a system that is capable of asking these sort of arbitrary questions.
I think, Austin, you hit the nail on the head there. Observability is really about understanding. When I think of traditional monitoring, it's always been about putting graphs on a dashboard and kind of watching for something to change on those graphs. And although those graphs and dashboards definitely play a role in observability, they tend to only really give you part of that picture. And too often they're kind of a result or an afterthought. We had an outage. What metrics didn't we have on our dashboard? Well, we better, go ahead and add it right here. But when I think of observability, I think of being able to really dig to the bottom of the behavior of a system while code is actually running that system. And being able to answer questions like, is the code doing what we expect it to? If a user is hitting an issue, would I be able to detect it? If an anomaly occurs, is it possible for me to dig into the cause of that anomaly right then and there? Or do I just have to wait for that anomaly to occur again? And I think observability is changing how software is being built by thinking about observing a system rather than using it as an afterthought.
And as you mentioned, the need to retroactively go in and add new metrics collection points to try and understand what happens in an anomalous situation rather than being able to automatically capture the necessary relevant context and information is the real game changer there. And I'm wondering what you see as being some of the biggest challenges in enabling people to capture that necessary information and do it in a cross-cutting way where it's beyond just the specifics of a single log line or a particular counter that you're incrementing when a particular function happens, or certain timers that are being collected, and just some of the overall goals of the OpenTelemetry project in how it's going to help people achieve that sort of holy grail of observability.
Sure. I think you raise an interesting point there, and I would kind of not turn it around, but why do people not do this already, right? There's a pretty pervasive view, I think, in the developer community that things like distributed tracing, things like observability are only for like big companies, your Googles and your Facebooks and your Microsofts, where you have just a eye-popping amount of services and dependent services and different line of business things and, unmanageable complexity, right? And I think that is really, that's an opinion that is kind of brought forth by an unwillingness to kind of grapple with the goals of our existing tools. Because far too often, no matter how many fancy dashboards you make, no matter how many, cool metric data points you put together, I think Alex had the right of it. A lot of times it's just like, we're making this dashboard to make this dashboard because this dashboard is sort of proof of life. This dashboard is the thing we can point to when someone says, well, is it up? So I think one of the goals of OpenTelemetry is to really help change this narrative. And I think we do that by using the fact that OpenTelemetry is so widely supported. It's has extremely broad support from many organizations, people you've heard of like Microsoft and Google and Amazon, a huge variety of monitoring and observability tool vendors. Also open source open source maintainers, people that are creating things like Jaeger or Prometheus, right? So because it has this broad support, that means that we can sort of push the point of integration away from the individual dev and maybe go down a step or two. I think it's a pretty common thought when you're trying to monitor an abstraction, when you're trying to observe an abstraction, you really want to go one step below it. So if I'm trying to understand the behavior of my application, a good way to monitor that is to kind of go to the application container, right? Is to go to the runtime and look at certain metrics and measurements there. With OpenTelemetry, you can have a similar sort of behavior where I would say a goal is to integrate it into things like Kubernetes, things like Spring on the Java side, or Flask on the Python side. So you're actually getting a more holistic view of what's going on very, very easily without having to spend a bunch of time doing kind of manual instrumentation code.
And in terms of the actual process of instrumentation, I know that one of the use cases for the SDKs is to automate some of that setup and be able to, out of the box, just start collecting useful information without requiring a lot of development effort up front, but then still being able to provide the option of adding additional collection points for different metrics and traces. And I'm wondering what the developer workflow looks like for actually being able to get set up with collecting those metrics and then being able to perform some useful analysis on them.
Yeah, so I guess there's kind of two ways of thinking about instrumenting an application, at least in the Python side, and I know it's true in a lot of the other SIGs as well. There's kind of what we call the auto instrumentation portion of instrumenting, which in the Python world means that we're basically looking at what libraries are going to be utilized by a certain application. And so if you go ahead and you install the auto instrumentation package as well as some of the auto instrumentation libraries that we already support, what ends up happening is you run a separate script to wrap your Python executable with, which is just called OpenTelemetry instrument. And it basically will go ahead and instrument all the libraries that you're using that have support for OpenTelemetry with like spans and metrics for those libraries for you. So that's the auto instrumentation piece. The manual instrumentation piece would still require application developers to go ahead and set up their SDKs and start spans or start collecting metrics and the different portions of their application that they're interested in. But a big piece of what we're trying to do here is we're trying to make sure that the correlation between the manual and the auto instrumentation all works, and all of the context flows through your application, and it also flows between the services along the wire.
And I think that context aspect is the real differentiating factor between just raw metrics of here is an integer that represents something, but you need to have enough internal context or awareness of the code base to understand what it means, versus being able to have that context propagate along with the metric so that it's a little bit easier for somebody who doesn't own the system to be able to understand what's actually happening.
Yeah, absolutely. I think context is absolutely critical here. Otherwise, all of that data is really just data that's floating in the air.
And stepping back up to the level of the more broad OpenTelemetry project and its mission, because of the fact that it is focused on support across a number of different language communities and runtimes and specifics of libraries and frameworks, I'm wondering how that benefits the overall broader software community and just some of the challenges that you face in avoiding the trap of limiting the entire capability of the ecosystem to the lowest common denominator that exists across those different runtimes.
I can speak to this a little bit. I think one of the things as like an OpenTracing maintainer, certainly, that we heard from the community was, for lack of a better word, people were, let's say, displeased with the quote-unquote Java-ness of the OpenTracing API, right? And from the jump with OpenTelemetry, there's been a pretty concentrated push to make the look and feel of OpenTelemetry feel very native in each language. So that really influenced everything from sort of spec writing, where there's been a pretty lengthy now project, a kind of cross-language compatibility SIG that is mostly looking at what are the words we're using in the specification? Are we making sure that we have kind of all the words we need in the spec to allow for individual languages to implement the spec in a way that feels native for that language? There's also a bit of hewing to kind of whatever the dominant patterns is, right? So I think if you look at outside of the real raw primitives, things like starting and ending a span, adding attributes or events to a span, a lot of the stuff around metrics, a lot of the up-down counters and things like that, outside of these very primitive sort of actions, there's a lot more flexibility in how that gets integrated into the native workflow. A good example I would probably point to is what's going on in the C# SIG. And I know we've used that word a lot. For people that don't know, SIG is special interest group. That's basically the primary way we're organizing the project around these languages or topics have SIGs. So the C# SIG is, Microsoft's very heavily involved in this project, and so there's actually a push to integrate OpenTelemetry into the .NET runtime itself and bridge it with sort of the existing, diagnostic information that is already available in .NET. And so you're seeing kind of this two-forked approach where you can use kind of just existing primitives in the .NET side of the shop that you might be already using or already familiar with as the .NET developer. And then with a simple bit of configuration change, those will hook into OpenTelemetry and start emitting OpenTelemetry spans, OpenTelemetry metrics that can then be forwarded to some other part of the OpenTelemetry ecosystem, like the collector component, in order to be exported elsewhere. I think with Python, you see something somewhat similar in where there's some idioms that are maybe, they try to make it pretty Pythonic, I would say. Go is very much like Go. A lot of it is making sure that each SIG has the ability to kind of change things as they need to, along with a pretty strong top-level community that can make sure that, hey, we're all on the same page, no one's drifted too far from spec or is kind of reinventing the wheel over here in a way that they shouldn't.
Yeah, and if I can just add a little bit to that, I think the specification is written in a way that's specific enough around the intent of a particular definition, while leaving enough room for languages to interpret it in a way that makes sense to the language. And another thing we've seen that has been pretty successful is around implementation or proposals around that we call OTAPs, which are OpenTelemetry enhancement proposals, which is basically just a process that we go through before making changes to the spec, where you're able to propose a change that you want. And one thing that we've seen work well is to actually have different SIGs implement an OTAP as a prototype, just to get an idea for whether or not a particular concept works in the language that is defined in each of the languages that we care about. And so that's kind of implemented at the SIG level by folks that are working in the language itself.
Yeah, I think the OTAP process has been very helpful for the project. And just sort of the requirement to show your work, something that maybe a lot of open source projects could look at. We didn't necessarily get, I'm not going to say we came up with it ourselves. It was Isabel Redelmeyer was actually a very strong proponent of OTEP, or the OTEP process, and helped kind of codify it originally. But I know she talked to people that were very involved with creating the KEPs, right? The Kubernetes enhancement protocols or proposals. I don't remember what the P stands for there, but that's where a lot of the inspiration was drawn from, I want to say.
Yeah, there are a number of different communities that have gone down that path where Python has its PEPs. I know Django has their own process for that. There are a number of other open source communities that are following on that. So it's definitely a good way to bring everybody into the conversation and ensure that you have as diverse as possible of inputs to make sure that you're not just getting tunnel vision on the way one thing should be implemented and bringing in the voices that are necessary to make sure that it works for the broader community.
Mm-hmm.
And then as far as the actual data that you're collecting for being able to gain some visibility into the systems, we've talked about metrics, we've talked about spans. I know that there's initial support for log collection and some of the way that those should be formatted. So I'm curious if we can dig a bit more into the specifics of the information that's collected, and then maybe in terms of the Python SDK, some of the available hooks into the runtime to be able to pull that information out and propagate it appropriately.
So basically, the types of information we're looking at collecting with the initial release of the project is really around the implementation and collection of distributed traces and metrics. That's kind of the initial goal. And basically, I mean, metrics could be anything from your memory consumption, CPU, or request timing, or whatever it is that you care about in your application. And then on the distributed traces, basically what we're worried about there is collecting traces and spans that are distributed across your different services.
One of the things I think is really helpful when you think about distributed traces is that in a lot of ways, they're really just semantic. They're structured logs, right? They're structured logs with context. And one of the things that we've done in OpenTelemetry is we've tried to sort of extend the span model a little bit and add a lot more semantic meaning to different fields, which is something that I don't believe is going to be like, this is not a, it's not going to revolutionize your life tomorrow, but in a couple of years now, I think being able to go and say like, okay, as a small example, the status field on a span in OpenTelemetry supports the gRPC status codes, right? So there's a lot of ways to actually classify the work that happened under a span in a semantically meaningful way. The difference between, for example, this failed due to a timeout versus this failed, the difference between a 400 or a 404 or a 405, right? But also things like, this was a context, the context for this request was canceled. So as analysis systems sort of catch up to the OpenTelemetry and start to implement the ability to use this data to kind of derive interesting statistical information about your system, I think you'll see a lot of interesting innovation happen in terms of building tools that can sort of really understand what's going on. Because one of the sort of last mile problem exists in OpenTelemetry, as it does with most monitoring observability things. You have all this data, great, but you still have to have someone that actually understands what the data represents in order to make heads or tails of it. But by focusing a lot on sort of having these semantically accurate spans, I think we'll be able to build better analysis tools in the future.
To get back to the question specifically around Python, so for the OpenTelemetry Python project, what we're really focusing on is just wrapping up the work around implementing the spec around metrics. And today, the implementation for tracing is already in beta, and we're already, I think, pretty close to being done. Yeah, so between the tracing implementation and the metrics implementation, that's kind of the interfaces that you'll want to use from Python.
And I know, too, that there is some initial work on being able to standardize on the formatting of log data so that it can be correlated with the spans and metrics that are being collected. I'm wondering how you are approaching that in the Python ecosystem, whether you're just working on using the built-in logging capabilities or leaning on something like the struct log project to be able to provide that structure out of the box and just define the specifics of it for the tracing capabilities, or what your thoughts are on that regard.
Yeah, so as the logging capabilities is fairly new in the conversation, we haven't, as a project, started looking at how we're going to implement it in the OpenTelemetry Python project yet. But I would suspect that we would want to lean on, as much of the standard library as we can, wherever we can.
It sort of adds some more color on the logging question. I think logging is incubating. It's still kind of in a very fluid process right now, but I think it's accurate to say that there's really no appetite in the project to create kind of a new logging API, right? There is a plethora of battle-hardened and tested and very good logging libraries out there, and I don't really think we're in the interest of competing with them. I believe at a really high level, I think it's actually what you said earlier was maybe the best way to describe it. OpenTelemetry has the semantic concept of linking different forms of telemetry together. So you could link a measurement from a metric to the span that occurred while that measurement was being collected, for example, or while that measurement was being measured. And I feel like some sort of adapter into, a logging adapter that allows those logs to be context sensitive would be one potential implementation result here. I think another might be, you could even maybe imagine something where if you have, logs that are already in a file format and they have some sort of correlation information, or, they're getting correlation information through OpenTelemetry auto instrumentation, and that's going in and that's editing your log, that's adding in the correlation IDs, identifiers. Then like a file beat style processor that is scraping those and then sending them off somewhere and adding in sort of the link through like the OpenTelemetry collector, for example. But this is also I think this is where the thinking is more so than where the reality is. I think the logging stuff is probably, I don't know if it's going to be beta by the time the rest of the project is in GA. I would maybe expect it to be more of in an alpha.
And then for being able to ensure that you can use OpenTelemetry across different languages and across different service boundaries, how are you addressing the question of feature parity within different SDKs and how to signal the feature completeness of a given implementation so that people can effectively evaluate them as they're building out and designing their systems and trying to gain useful observability metrics?
Yeah, that's a great question. I can talk about it kind of in the high level, but at a high level, you can think of there being three sort of big moving parts. There's the API, there's the SDK, and then there's OTLP, which is the wire format for actually representing the trace and metric data. So the API, once we have API at like a 1.0, and I would even suggest right now the API is pretty close to 1.0. But once we have that, then that API will most likely change very slowly. The SDK you would expect can move a little more quickly under that, but I would also suggest that the OTLP, the wire protocol, will also probably change slowly. So one of the goals of OpenTelemetry was to make sure the API and SDK were decoupled. So as long as you're using the same API level on both sides, you could actually swap out individual components if you need to, assuming that you aren't violating, that you aren't breaking the API. And then since you can sort of independently upgrade the SDK components, with OTLP is sort of the fallback, and I don't want to say fallback, but the default way to export data. You can kind of do whatever you want in the middle, and the middle can move very quickly. but it needs to start out in a pretty slow way and it needs to end in a pretty slow way. So you're not going to be able to, you could definitely see extensions or little side projects popping up that add some valuable feature that would need to be marshaled into working through the existing API or and then being exported through the existing OTLP format.
To get back to the issue around feature parity, I think the process we've taken to address feature parity across different languages is to basically create tracking issues for any spec changes and address them as they come in on a sig by sig basis. So for each language, basically. For example, before the beta was released, there was a list put together by the technical committee for OpenTelemetry of all the features that we knew we needed to implement for the beta to be complete. And so basically it was up to each SIG to then go off and ensure that the list was implemented within their own language. And anything that wasn't implemented, we would just go ahead and create an issue for and track it that way.
For the most part, it's actually maybe less of a huge concern because the real basic primitives, things like context propagation, we're defaulting to W3C trace context specification. And I know there's like a bunch of other stuff sort of upcoming from trace context, but the primitives are really well defined at this point. And you could even, as long as you're using the same sort of context propagation everywhere, then the individual hops don't mean as much. Like, let's say I had 5 different services, as long as they're all using the same context prop, then I'll get an unbroken trace, right? I'll get an unbroken set of tags on my metrics because that's all being sent around in a way everyone understands. And there should be, reasonable fallback. So, if something new comes in, it goes into an additional field and service B has been updated and it understands it and the rest of them haven't, then you would obviously have service B is maybe something new is happening here, right? That isn't happening everywhere else. But the basic functionality of tracing hasn't broken for you because you updated.
And digging more into the specifics of Python and the SDK implementation of it, can you discuss a bit about how that is actually implemented and some of the initial design decisions or assumptions that were made early on that had to be revised or reconsidered as you got further along in the implementation of it and the overall adoption of its use?
Yeah, I guess I can't think of too many assumptions that have been changed since we have started seeing adoption just yet. I think we might still be a little bit too early in the project, or any assumptions that were made and changed might be predating my time on the project. But I guess one of the more recent changes that occurred was around the propagation of context, where initially we didn't have a context API, what we call the context API in OpenTelemetry. And so we did have to go back and find a way to separate out that context API from the implementation that we were using. And so that was a fair amount of work. But I can't think of other ways that we really had to rework a bunch of the assumptions that we'd made originally.
I can't either. I feel like, admittedly, most of my work is at the community level broadly, so I don't necessarily know about all the individual SIGs. But Python's always felt like it's pretty much on the rails. I think some of that is actually just a credit to sort of the people in the SIG, obviously, but also Python just at a pretty basic level. It has all the features you really need, so you don't have to do, here's a good example, I can say. In process context propagation. So if I have a process and then I have a span and then I have a function that I want to trace independently, or I want to create a span for independently, and I'm using multi-threading of some sort, then I need some thing to sort of marshal, okay, what's the active span at any given point? And Python really just has all the tools you need to kind of code that out of the box. You don't have to deal with manually passing stuff around like in Go. You don't have the sort of wonky support story you have around that like in JavaScript. Since there's no threads, there's different ways to kind of do this. So for the most part, Python has just chugged along very merrily while other SIGs were trying to kind of glom everything together. Python, and I think it's also partially just Python's pretty popular, so there's already been OpenTracing and OpenCensus both had very good Python support. And so there hasn't really been a lot of like, oh, we need to like invent this thing. It's more like, well, we've done this in the past, so we'll do it, this way, but we'll make it more performant or whatever.
And then for being able to gain compatibility and visibility into the broader ecosystem, I know that there are specific libraries for things like Django or Flask to auto-instrument the peculiarities of those frameworks, but what is the overall strategy or approach for being able to gain broader adoption within the overall ecosystem of web or data or, just networked systems, things like that?
That's a really good question. So, we started out by providing instrumentation for libraries that we know are fairly popular frameworks. So, like you mentioned, the Django, the Flask requests, and what we started seeing is that there's interest from contributors and maintainers of other frameworks to build instrumentation libraries that are compatible with OpenTelemetry for their own projects and add to the list, which is actually really exciting because those folks know the tools and the libraries inside and out. And as far as a scaling strategy, it's a lot more scalable to have folks that are involved in those projects directly contributing instrumentation than to have someone from the OpenTelemetry project go out and learn everything there is to know about any particular libraries. So I think hopefully that's kind of where we're going to be driving as OpenTelemetry gains popularity. And one thing that we've seen in for example in the .NET world, which I think Austin alluded to earlier, was that there's plans to adopt OpenTelemetry in the language itself, which is kind of the best possible solution for adoption of any particular standard.
Yeah, I think as a strategy, really our goal as a project is to provide sort of stable interfaces, good quality SDK design, and a support plan, right? Like we need to be good shepherds and stewards of what we've built and give people the confidence that they can go and they can do these integrations, right? And that we will be able to support them through that by not boiling the sea every 2 months. I think beyond, into this broader ecosystem, like you said, approaching and thinking about how do we integrate this into, more services, more, you can think like managed resources, things like cloud providers and their SDKs, or make this available through APIs. If you, like, let's say you used a database API or a GraphQL, library to query something, maybe getting the person that serves that API to also have OpenTelemetry traces and then be able to independently sort of return those to you so that you could actually inspect the performance of your request as it goes across the WAN into some other system. And then same thing with maybe you're running your own database, right? Like, is there a way that we can get OpenTelemetry into MySQL or into Postgres or into Mongo? But I think that goes back to, the way that will happen is by running the project well and having it be stable and have good release management and, make it something other people can build on.
Yeah. And just one more thing to add there. I think it's also important to make it as easy to use the libraries and the APIs as possible for anyone who wants to provide that instrumentation, so that they don't have to spend a tremendous amount of time just learning how to use a particular tool to be able to provide benefits of using that tool for their users. And so I think one of the things that we're spending some time on in the Python SIG is around providing like an interface for anyone who wants to provide auto instrumentation for their library through the base instrumenter class, and also providing the examples for how some of the other instrumentations have gone through and actually been instrumented.
And then once you have instrumented your application, you're generating all of these data objects and context for being able to understand what's happening in your system. You still need to have somewhere to send it to and perform analysis on it. So what are some of the existing options for that? And what are some of the ones that are upcoming that you are keeping an eye on?
Yeah, it's a great question. So one of the things that I think that OpenTelemetry really dramatically simplifies is the deployment of telemetry through tools like the OpenTelemetry collector and through kind of a native format like OTLP. So what we're seeing is more organizations start to adopt OpenTelemetry protocol as kind of like a native ingest format. I know, like at Lightstep, we actually, I don't know if we've like publicly announced it yet, but it's there, so I'll talk about it. But we'll be accepting OTLP formatted data to our SaaS backend very soon. Like the work is done, and I think it's actually in public right now, but we haven't updated the docs yet. So, but in a sort of bigger picture, I think having the OpenTelemetry collector be this vendor neutral way to, aggregate traces and metric data from multiple different sources, and then export them to a variety of backend systems. Some of which will be open source. Like Jaeger has already come out and kind of pledged adoption to, or said like, hey, we're going to switch over to using the OpenTelemetry collector instead of our own. I would expect other sort of open source projects to analysis tools to start following. You also have the ability to write your own exporter, and we've seen a lot of adoption in that. So companies like Google, Microsoft, Splunk, Honeycomb, who else? There's probably a few I'm forgetting. Datadog. Has Datadog, I don't know, have they done a exporter yet?
Yep, in Python there's an exporter.
But either way, the collector makes it very easy for you to sort of to really have a separation of concerns between the people that are maybe integrating OpenTelemetry into their code base and then the people that are sort of responsible for collecting all that data and sending it somewhere. Instead of having to redeploy your application for a config change, you can redeploy your collector and say like, okay, I want to send this to some other place now. So that's very cool. And then because the collector is also completely open source, you can transform that data however you like. So one of the things that I'm kind of keeping an eye on that I've been talking about is like, hey, you could just write, you could convert your traces to analytic events, right? And then you could send them to an analytics provider, or you can turn them into JSON and do whatever with them, right? You can put them in a big data thing and do all sorts of fun queries. I think it's going to enable a lot of interesting tools that we haven't seen yet. Things like using traces as a part of automated testing to validate application behavior or logic flows, right? You can sort of imagine a situation where maybe in test I have a ton of instrumentation about what's going on in my application, and maybe I turn some of that off for production or whatever, but being able to sort of take all that out as a dump and then just do a diff against the last time you ran it to see what's changed. Like, am I calling someone else? This is a new external API, or did I pick up a new service dependency or whatnot? That sort of stuff I think is really cool.
And then in terms of your experience of working with the OpenTelemetry community and working on the specification and some of the SDK implementations, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think for me, on the challenging side, I think it's just how hard it is to get collecting telemetry right in a way that's both easy to use and useful to people. I think that's been really challenging. And I think the most pleasant surprise by far has been just watching so many different people from so many different organizations working together and trying to solve these really hard problems. I think it's been a really, really great experience. So if anybody's out there looking for an open source project to join, I think this is a great place to start.
Yeah, I'll echo most of what Alex said there, or I'll echo all of it. But I think there's this there's a perception issue, I guess, in the open source community more broadly that that quote unquote vendor projects aren't good projects, or that they're not reflective of actual community values. And I think in the case of OpenTelemetry, I would suggest this is maybe the counter example where yes, this is a very vendor-y project. Most people working on it are working on it. I mean, they're passionate about the subject, but they're also working for companies that are invested in it, right? That said, I think any kind of project you have that is so impactful to the bottom lines of these companies, it's been fascinating to see how how much people are just coming together for the good of the project, right? There hasn't really been a lot of bad blood. There's not a lot of like side taking, like, oh, well, we think this way because our employer thinks this way. People are genuinely engaging in really good faith. And I think it's brought what is normally a pretty interesting industry together. And it's cool to see a bunch of people that's like, hey, we work for different places and our companies are competitors, but in here, we're all cool, we're all friends. We're all trying to, solve this very tricky problem in a really good way.
Yeah, and I really like the just general industry trend that I've been seeing in a lot of different areas of technology of trying to standardize on the interfaces that are used for interoperability so that the different specific implementations of open source or vendor technologies can innovate on the specifics of how they operate and the capabilities that they provide, rather than trying to lock people into their solution because they're not compatible with the import or export options for the other systems that you might want to compose together with them.
Yeah, 100%.
Yeah. There's nothing worse than having to learn a whole new set of tooling and languages just to make something work with a particular vendor.
And then in terms of the OpenTelemetry project itself, what are the cases where it's the wrong choice and somebody might be better suited just using a standard approach to metrics and logging for being able to gain understanding into their system?
That's a tough one.
Is never an option?
That's definitely an option.
I think there's probably, it's an interesting question, right? Because there's obviously times that it's the wrong choice, but that's less of a technical consideration than it is sort of a cultural one. I think I think it's broadly applicable and it's generally worthwhile to pursue OpenTelemetry, especially if you are in an organization that can kind of handle it and adapt to it. But I think there are wide classes of applications that maybe don't benefit from example, tracing adds overhead, not a ton of overhead, but it does. Tracing on the front end, especially right now, will increase the amount of JavaScript your browser has to download. That can be a problem for people. And if it's a disqualifying problem for you, then okay, use something else, right? We'll try to fix it. We'll try to make it better. But I'm not out here saying oh, it's perfect, and if you don't use it, you're an idiot. I think a lot of, maybe embedded devices or things like that, you're probably not going to get the mileage. If you don't have a distributed system, it maybe is a little less useful for you. That said, 80% of the time, it's probably, if not the right answer, it's at least a good answer. And the one thing I would say is, if you're listening to this or you're thinking, the time that it's always the right answer is if you're thinking about trying to do it yourself. Right? If you've looked at your system and you said, I need distributed tracing, I need the sort of things OpenTelemetry can do, but I want to build it myself, then it is 100% the right answer to use OpenTelemetry. Because I can guarantee you that collectively, we have probably put more thought and time into building OpenTelemetry than just one person can, right? Now, you don't have to use OpenTelemetry with Lightstep. You don't have to use it with Datadog. You don't have to use it with any specific vendor, right? I'm not saying oh, you have to pay us money. I am saying don't, there's a cost for everything, and going your own way is going to hurt more in the long run than anything it saves up front in terms of either time or money.
Yeah, so I'll echo what Austin said there, but also I think it's important if you're looking at OpenTelemetry and you think, oh, it's not doing the thing that I want for my special case or whatever it is, I think it's important to get involved with the community and actually bring that case up, because it's likely that other people have also run into the same problems or limitations or whatever it is that's preventing adoption of OpenTelemetry as it is. And so I think it's good to have that conversation and at least try to understand all those use cases. Even if it's not supported today, it doesn't mean that it won't be supported tomorrow. And I think that's something that we're always looking forward to. And
so as you look to the next steps and the near to medium future of OpenTelemetry, what do you have in store for it as far as plans and feature capabilities? And what are the areas of contribution that are most vital as you continue down the path of completing the general availability roadmap and moving beyond that?
I mean, I can speak kind of to my side of things. At a big picture, I think more integration, more auto instrumentation, really trying to make it easy and fast for people to onboard and start using it and getting value from it. That's what I see, this year, right? Like we've got kind of the basics done. We're implementing metrics everywhere. Now let's make that useful. In terms of what I would love to see people kind of coming in and doing, if you're listening to this and you want to get involved, the two things we really need are, one is user feedback, so people to actually try it out and use it and tell us what doesn't work, and also tell us what works. But also, if you want to go teach people about this, if you want to educate people about this, we would love to have more people kind of involved in the community, helping out, writing documentation, doing examples. It doesn't have to be on our website, on the OpenTelemetry site. It can be anywhere. Do it on dev.to or put it on YouTube or whatever. But if you are interested in that, we actually have resources at our website, OpenTelemetry.io. Under the documentation, there's like a learning resources section where you can actually, I know no one's doing in-person meetups right now, but, we actually have like a workshop there that you can adapt and use. Maybe you want to do a lunch and learn at your company. You can pick up our slides and use those to teach other people OpenTelemetry, which I think is a great way to get involved, even if you don't want to, really get down in the weeds in GitHub.
Yeah, and I think specifically around Python, as you mentioned, Austin, reading the docs, trying out the examples. We have the OpenTelemetry Python Read the Docs website that is up there, and we would love to get some feedback on that. And from a contribution stand, we would love to see as many folks that are interested in implementing instrumentation for OpenTelemetry as possible come in the door and attend our SIG meetings or join us on Gitter. We're pretty accessible.
Well, for anybody who wants to get in touch with either of you or follow along with the work that you're doing or contribute to OpenTelemetry, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose the Pulumi project. I've started adopting that for managing my own infrastructure and have been enjoying being able to just write some Python and take advantage of all of the ecosystem tooling around that for being able to build out my cloud resources. So definitely recommend taking a look at that if you're, even if you're running existing infrastructure and you want to start converting over. It has great options for adopting existing resources. So definitely worth a look. And with that, I'll pass it to you, Austin. Do you have any picks this week?
I've been using a lot of Helm 3 recently. I've been getting more back into Kubernetes. And wow, I tried Helm when it was years ago, or I guess when it first came out. And the headaches of configuration and setup and tiller and all that were extremely frustrating. And I felt made it a not great experience. But Helm 3, they really came around, and it's exactly what you want it to do. It templates things, and it just works, and it's one binary, and you don't have to install or configure stuff. It's great. I love it. If you've seen Helm before and been burned by Tiller or by RBAC or anything else, definitely recommend giving Helm 3 a shot.
And Alex, how about you?
Yeah, so I guess my pick of the week is Algorithms to Live By, The Computer Science of Human Decisions by Brian Christian and Tom Griffiths. It's a great book talking about how algorithms can be used in everyday life for applying, computer algorithms to how to make decisions as humans. It's actually a really great and entertaining read.
Yeah, I enjoyed reading that one myself, so I'll second that pick. So I'd like to thank the both of you for taking the time today to join me and discuss the work that you're doing with OpenTelemetry. It's definitely a very interesting project and one that I plan to start adopting for my own system. So I appreciate all of the effort that you and everyone else involved has put into it, and I hope you enjoy the rest of your day.
Great. Thanks for having us.
Yeah, thanks for having us, and looking forward to your feedback.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.